Hi everyone and welcome to this episode of Keipert Labs. Today we're going to be looking at calculations involving KEQ, that is the equilibrium constant. So we're going to recap the law of mass action, we're going to look at how to calculate the equilibrium constant, and then we're going to go through a couple of examples involving KEQ, looking at how we can, the two types of calculations that we might do. So firstly, the law of mass action. We looked at this idea that for this equilibrium reaction, A and B reacting to form C and D, with the lowercase letters being their coefficients, that the ratio of their concentrations is constant for a given temperature. We can calculate it using the equilibrium expression, where we've got the concentration of the products raised to their power of their coefficients divided by the concentration of the reactants raised to the power of their coefficients. Pork, products over reactants equals K. So we see that this ratio is a constant value. But now, how do we calculate with this value and what can it tell us? Okay, so just remember that pork acronym. So remember that, so what it allows us to do, two types of calculations. The first one is that we can use the concentrations present at equilibrium to calculate the equilibrium constant, or we can use the constant to calculate the concentrations at equilibrium, and once we've reached equilibrium for one or more substances in the equation. So we've kind of got both directions that we can go. Do you calculate the constant, or do you use the constant to calculate concentration? Okay, I'm going to show you how we do both. Okay, so let's look at an example here. So we've got a 2-litre container with a mixture of a certain number of moles of hydrogen, iodine, and hydrogen iodide in equilibrium. And then we have the equation here. So H2 plus I2 forms 2HI. So we're going to calculate the value of KEQ. Now the first thing that we have to do is that one of the things that we've looked at before is this idea that it works with concentrations. So we need to convert these mole values to moles per litre values first. Okay, so we know that it's a 2-litre container. So in order to work out concentrations, we divide our number of moles by 2 litres. And so we get these three values for concentration for each of our substances. And now what we need to look at is our equilibrium expression. Okay, so we've got HI squared over, so product HI squared over H2 times I2. Okay, each of these is to the power of 1 because we've only got a coefficient of 1. And now we substitute in the numbers that we know. Okay, the concentration of HI, of H2 and I2. We calculate these together and we get a value that's 48.1. Now, you notice here that there's no units. One of the things that's important with K is that it doesn't have any units. And part of the reason for that is that the exact construction of this equilibrium expression, you may, if you included the mole per litre units, that sometimes they cancel out and sometimes they don't. By convention, what we do is we say, right, we'll just ignore the units. It's a constant number, and so having units in there is unnecessary. Okay, let's now look at another example where we can calculate concentrations. Okay, so we've got an equilibrium constant of 0.400 at 250 Celsius. Remember, the concentration, equilibrium constant that small means that you've kind of got a mixture of reactants and products at equilibrium. Okay, so we've got phosphorus pentachloride, phosphorus trichloride, and then chlorine gas in equilibrium in this expression. Okay, so in an equilibrium mixture, we've got these concentrations of PCl5 and PCl3. And then what's the concentration of Cl2 in this mixture? So we need first to look at our equilibrium expression. Okay, so we construct our equilibrium expression. There's no squares or cubes or anything else like that because we've got coefficients of 1. And so then we substitute in what we know. Now in this situation, we know our equilibrium constant. The thing that we don't know is our chlorine concentration. So it remains our unknown, or it's X, for example. Okay, we can rearrange our expression so that Cl2 is the subject of our equation. We have we can be working with our numbers here, and we get 0.80 moles per litre is our concentration of chlorine at equilibrium based on this ratio. Okay, so we've been able to work with our K value. The K value is either calculating what K is based on concentrations and also using K to help us calculate unknown concentrations. We will also be able to take K and work it out if we don't know any of the concentrations, provided that the circumstances are right, based on using a little bit of algebra to kind of work this out. Okay, so we recapped the law of mass. It's not the law of mass effect, so it's a typo. It's a law of mass action. We have looked at how we calculate the equilibrium constant, and then we've done some examples of calculations involving KEQ. Thanks very much for watching. Don't forget to like and subscribe. Bye for now.